So for the first episode of this math thing, we're going to do simultaneous equations. This will normally be taken on around the third quarter of M5. Yeah, so there's questions in the book. I'll put them in the description of the video. So here we have two equations. As you can see, they're linear equations, means you could graph a line from them. As you can see, both of these equations have two unknowns. They both have a y and an x variable, which means that we can't solve them because it's two unknowns and we don't know what either of them are. So we have to solve them together, simultaneously. So what we do is, because we know that y equals 2x squared minus x minus 2, and y equals 4x plus 3 plus 1, we can just sub this into this equation as y. So we can do this either way. We could take this and put it in here as y, but it doesn't really matter. But what we're going to do for this one is take 4x plus 1 is equal to y and put it in as y as the other equation. So that leaves us with 4x plus 1 equals 2x squared minus x minus 2. Yeah. So this is now a quadratic equation. And with a quadratic equation, what you want to do is make it equal to 0. So how do we do that? We first minus 4x from this side and minus 4x from this side. That will cancel out 4x on this side, and then just add a minus 4x to this side. So that leaves us with 1 equals 2x squared minus x minus 4x minus 2. And then we just minus 1, same principle. And we have 0 equals 2x squared minus x minus 4x minus 2 minus 1. Okay, this may look a little bit scary right now, but what the next step for us is to cancel out the or to add the like terms, right? So we got x here, so we can add them. So that leaves us with 2x squared negative 1x, because there's a 1 there, you start show. Negative 1x minus 4x, it's negative 5x. Negative 1 minus 1, it's negative 3. So that's what we've got right now. So there's no way to further add like terms because we've already done that. So now we can either factor. By factoring, you need a number that will basically multiply to make 3 and add to make 5, but there isn't one because there's only 3 and 1 to multiply to make 3, and those don't add to make negative 5. So we can't do that. There isn't a common variable, so there's no number that can divide by 2, 5, and 3. So we can't divide. So what we need to do is use the quadratic formula. So you've probably already done this by quarter 3, but it works with all quadratic equations. It's x equals b, negative b, plus or minus the square root of b squared minus 4 times a times c over 2a. And again, that might look really scary, but when I'm about to explain it, I think it'll look a little better. So basically, we have these unknowns. We have b, a, and c, right? And what we do is, because we have a nice x squared here, we have a number with a coefficient of x, and then we have a number on its own. We can give these numbers these letters. So it has to be this order. The number on the x squared is always equal to a. The number with the x as a coefficient is always b. And then the number on its own is always c. Okay, so now all we have to do is plug them into the equation. So I'm just going to move up here. So we have x equals negative b, but b is already negative. B is a negative 5. So what we do is we just make it positive, because 2 negatives makes it positive. So we have x equals positive 5 plus or minus the square root of negative 5 squared. That's a little difficult to see. Minus 4 times a, which is 2, times c, which is negative 3, over 2 times a, which is 2. So that's what we've got. Alright, so moving on, we can just start to solve. So we can't do anything with the 5 plus and minus yet. In the square root, we have a negative 5 to the power of 2, or negative 5. Yeah, negative 5 to the power of 2, and that's, we can't do, like, you can't have negative 5 squared, right? A negative squared is always a positive. If you square any number, it's always a positive. So that leaves us with basically 5 squared, which is 25, minus, well, okay, so it's not minus, it's plus, right? Because we've got negative 4 times 2, which is negative 8. And then we've got negative 8 multiplied by negative 3, which makes positive, which makes positive 24. You can just put that into your calculator. Positive 24. Right, so that's over 2 times 2, 4. Hope you see how we got that. You can always just rewind the video. So now we've got 5 plus or minus 24, 25 plus 24 plus 49. Again, you can just put that in your calculator. 49 over 4. Okay. So now we can just, because 49 has a nice square root of 7, we can just do that. See, because the square root of 49 is 7. 7 squared equals 49. 7 times 7 is 49. So we go over 4. Okay, so the next thing we need to do is to start to, because we have a plus and a minus, right? We have to do this twice. We have to do this equation twice. So we have 5, one option is we have 5 plus 7 over 4. And the other option is 5 minus 7 over 4. Alright, so you can just put it into your calculator, but basically 5 minus 7 over 4 equals negative 2 over 4, which will give you negative 0.5. It's not on the screen, okay. So yeah, so what we did was 5 minus 7, it's negative 2, and then we just did over 4. We didn't do anything with the 4 that time. So then you have negative 2 over 4, which will give you negative 0.5. You can just put this directly into your calculator. I just don't have a calculator right now. So 5 plus 7 over 4 will give you, it'll give you 12 over 4, and 12 over 4 equals 3. So you've got your two x variables right there. Right? So you have, for one, I'm just going to move to a new sheet of paper very, very quickly. So I hope you see what we got there. The 2x values. I'm just going to leave it on the screen for a second if you want to like take a screenshot or something, I don't know. Alright, so moving on. So we have, for our first x variable, we have x equals 3. Alright, so what we need to do now is plug that back into an equation, to one of our original equations. So either y equals 4x plus 1 or y equals 2x squared minus x minus 2. For me, y equals 4x plus 1 is easier. It's a 2-step, whereas this one's a lot more. You can put the x equation back into either of the equations, it doesn't really matter. The x value back into either of the equations, it doesn't matter, you get the right answer either way. But it's better if you choose the easier one, and this is the easier one. It only has one x value, and you just do 4 times x and then add 1, so it's only a 2-step process. So that's what I would do. So you have that, x equals 3. So now you have, so if x equals 3 in this equation, right? So that's what you're doing. You're just putting this as that in there. Y equals 4 times 3 plus 1. So y equals 13. So you have one of your answers. So you want to always keep the x and y value together. So if from 3 you get 13, from the x value 3 you get 13, you have to keep those together. Always. So one of your answers, I'm just going to put the answer, I'll put the answers in this little box right here. So one of the answers is 3 and 13. Remember the x value always comes first when you're doing this. So this is a coordinate point, so you could plot it and see the line. The other x value you got was x equals negative 0.5. Sure, actually that sounds good. So negative 0.5 is the other x value. So again, you can just put it back into the equation. So if y equals 4x plus 1 and x equals 0.5, we can solve it now because there's only one unknown, and that's y. So y equals negative 0.5 plus 1. Okay, and that equals, you just put it in your calculator, but y times negative 0.5 is negative 2, and then plus 1 is negative 1, so it's negative 1. So your other answer is 0.5 and negative 1. Negative 0.5, sorry. And negative 1. So that's how you do a simultaneous equation using the quadratic formula.